Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Afif Rifai bin Aziz. So basically I'm from Group 9 and this is our presentation about engine blocks. So first of all, I will introduce the group members. So the first one is myself is Muhammad Afif Rifai bin Aziz. Second is Muhammad Amirul bin Abdullah. Third one is Muhammad Afnan Fikri. And the fourth is Muhammad Akmal. And the last one is Muhammad Alif bin Nordin. So now I will start the introduction of the topic. So the engine block is the foundation of an internal combustion engine, housing key components and forming the main structure to the other parts that are attached to. So some of the details is function and importance. So the first one is core structure. So the engine block forms the core structure of an engine, housing the cylinders where the pistons move up and down. So this movement is crucial because of for converting fuel into the mechanical energy. So the next one is component housing. So it's housed various engine components such as the crankshaft, camshaft, and sometimes the oil pump. So it also contains spaces for coolant and oil, which are essential for engine cooling and lubricant. So the last one for is which is the heat dissipation. So for the heat dissipation, the engine block is designed to dissipate the substantial heat generated during combustion and preventing the engine from overheating. So the next is the material used. So the first material used is cast iron. So traditionally, engine blocks were made from cast iron due to its strength and durability. So it is still used in many applications but has been largely replaced in modern engine. So the next one is aluminium. So modern engines often use aluminium for the engine blocks because of it is lighter, and aluminium blocks typically have iron or steel liners in the cylinders to handle the wear. So the last one is manufacturing process. So the first manufacturing process is casting. So the engine blocks are typically cast from molten metal. So this involves creating a mold, pouring the molten metal into the mold and allowing it to cool solidify. So the next one is machining. So on cast, the engine blocks undergoes machining process to achieve precise dimension and smooth surface for the cylinders. So crankshafts, bearings, and other mounting points. So the last one is quality control. After the machining, the engine block is subjected to rigorous quality control checks to ensure it meets the specification and has no defects. So the next one is problem statement. So detailed process of manufacture needs to be done for block engines to meet sustainability and performance objective. So the engine's blocks consist of CNC process and sun casting process, which the process that we have been focused for. So a detailed process need to be done and for the products which is then been coated to avoid corrosion and rust. Um, the initiative highlight casting, the CNC machining and finishing as the three crucial manufacturing process in the context of sustainability growth. Steps are done to improve sustainability by recycling the extra metal for use such as melting and use it in other operation. So we aims to explore this challenge comprehensively, identify barrier to sustainable manufacturing in engine blocks production, and propose strategies to enhance sustainability while maintaining or improving product quality and economic viability. Now we move to the objective of the topic. So the first objective is to identify manufacturing process issues. So which is to pinpoint and understand the challenge within the manufacturing process of engine block. So the second one is explore sustainable elements in engine blocks manufacturing. So, which is we need to examine and elucidate the connection between sustainable elements and the manufacturing process of engine blocks. So, the last one is develop sustainability concepts for engine blocks manufacturing. So, we need to formulate and propose sustainability concepts that can be integrated into the manufacturing of engine blocks.
Assalamualaikum, my name is Muhammad Alif Nuruddin, my chip number AD210142, and I will explain about detailed explanation of engine block. The engine block houses all of the major components that make up the bottom end of a motor. The block, which is also known as a cylinder block, is where the crankshaft spin and the piston move up and down is in the cylinder bores, followed by the full combustion. On some engine design, it also holds a camshaft, usually made from aluminum alloy on modern cars. On older vehicle and truck, it was commonly cast iron. Its metal construction gives it strength and the ability to transmit heat from the combustion processes to the integral cooling system in an efficient manner. Aluminum blocks typically have an iron sleeve presses into them for the piston bores or the special hot plating applied to the bores after machining. The block was originally just a block of metal holding the cylinder bores, the water cooling jacket, oil passage, and the crankcase. This water jacket is as it's sometimes known in the empty system of passage, circulating coolant in the engine block. The water jacket surround the engine cylinder, of which there are usually four, six, or eight, the which is contain the piston. For design of a engine block, the design of an engine block is a complex process that integrates various mechanical, thermal, and material considerations to ensure optimal performance, durability, and manufacturability. Here are the key aspects of the engine block design. For the first one is material selection. Aluminum alloy or cast iron are the two main materials used to make engine block. Because of its exceptional strength, resilience to wear, or longevity, cast iron is a good choice for heavy-duty application. On the other hand, because of aluminum alloys are lighter, the vehicle's overall weight is decreased and fuel economy is enhanced. The cost thermal ca- the cost thermal characteristic and manufacturing process are impacted by the material selection. For the second one is cylinder configuration. Within the engine block, the cylinder configuration might be inline, V-shape, flat, or W-shape. Every configuration affects the engine size, balance, and performance and has benefit on its own. While flat engines offer remarkable stability, V-shaped engines offer a lower center of gravity and higher power. W-shaped engines combine higher cylinder counts in a small package, and inline design are more straightforward and compact. For the third one is cooling system. The longevity and performance of engine depends on effective cooling. A system of coolant passage built into the engine block allows coolant to flow around the cylinder and other important parts of the engine. By distributing the heat produced during combustion, this passage is in avoiding overheating and preserving ideal operating temperature. Engines damage can be prevented by minimizing hot spot and ensuring uniform cooling through proper design. For the fourth is a lubricant system. Oil passage and galleries are built into the engine block to guarantee that the moving parts are properly lubricated. Engine oil can reach vital parts like the crankshaft, camshaft, and piston ring thanks to this passageway. Proper lubricant minimize wear, lower friction, and aids in cooling engine component. The oil system design must guarantee consistent oil delivery in all operation scenario. For the last one is structural integrity. The engine block needs to be robust enough to endure the intense force and pressure produced during combustion. It has strengthened section where the crankshaft is housed like the main bearing support. The block design includes webbing and ribbing to increase strength and rigidity while reducing weight. The structural integrity of the block is optimized using advanced computer-aided design, CAD, tools, and finite element analysis. So, in summary, the design of engine block is a comprehensive process that balances material properties, structural integrity, cooling and lubricant efficiency, manufacturability, and integration of components. Advanced design tools and manufacturing techniques are employed to create engine block that meet stringent performance, durability, and the cost requirement. Dimension and material of engine block. For the dimension of the engine block, it was different for each car that was produced. There are a lot of size, shapes, and design of engine blocks. V6 engine blocks widely used in a range of vehicles from sedans to SUV. Generally measure approximates to 40 to 60 centimeter in length, 50 to 70 centimeter in width, and 40 to 50 centimeter in height. In this project, one of the brand car, which is Nissan GTR, was chosen for understanding the dimension of its engine blocks. This dimension ensure a compact yet powerful configuration that fits well within various engine compartments. V6 engine blocks are commonly made from cast iron or aluminium. Cast iron blocks are known for their durability and ability to withstand high temperature, though they are heavier. In contrast, aluminum blocks are lighter, enhancing fuel efficiency and vehicle performance, while often incorporating cast iron or steel cylinder liner to combine strength with reduced weight. Summary of the product. The engine block is like the backbones of a combustion engine, playing a role in supporting key functions and components that makes the engine works. Usually made from either cast iron or aluminum blends, the block contains the cylinder, crankshaft, and piston of the engine, providing a structure that can withstand temperature, pressure, and mechanical strains. Inside the block are a pathway for coolant to regulate temperature by moving around the cylinder, and oil channel to keep moving part lubricate, reducing friction and extending the life of component. The material choice between cast iron for toughness in heavy duty uses for aluminum for vehicle affect how well the block performs. Precise manufacturing method like casting and machining ensure the dimension and structure strength to support engine function. Furthermore, the block includes parts such as a cylinder head, oil pan, and attachment point for accessory, consolidating all aspects of our engine operation for reliability.
My name is Muhammad Afnan Fikri bin Muhammad Zabah, and now I will talk about making engine block using sun casting process. The first step is pattern creation. The pattern is designed to include all the internal and external features of the engine block. Next is mold preparation. The pattern is placed inside the mold box and surrounded by special sand mix with a binder to hold the shape. Next is pattern remove and mold assembly. The pattern is carefully removed from the mold, leaving a cavity in the shape of the engine block. Next, pouring the molten metal. The molten metal is then poured into the mold through the gates, filling and mold cavity completely. Next, mold breakout and cleaning. Once the metal has cooked and solidified, the sand mold is broken away to reveal the rough engine block casting. Next, finishing and machining. Excess metal from the gates and races is trimmed of the casting. And last step is inspection and quality control. The finished engine blocks inspected for defect, dimension, and quality. Sand casting is an affordable process, particularly for small to medium-sized production runs. Comparing sand mold and pattern creation to other process like investment casting or die casting, The initial setup expenses are comparatively inexpensive. Because of this, suggesting is a feasible alternative for making engine block in lesser quantities for prototype early production runs or specialized or limited edition vehicle. Sandcasting also make it simple to alter the mold design, which makes it appropriate for iterative design procedures and customization.
Assalamualaikum. My name is Muhammad Ahmad. I will be explaining about the CNC machining process. For the first step, we must know the software that we need to use for CNC machine, that is computer aided design and also software of computer aided manufacturing. In computer aided design, it is to create a detailed 3D model of the engine block, including all necessary features and dimensions. Next, we go to the computer aided manufacturing. It is a tool part that are generated based on the CAD models that already we do. This is involved specifying cutting tools, fits, speeds, and machining operation. Next, we go to the material selection and preparation. Engine blocks are typically made from cast iron or alloy. The raw material is chosen based on the engine requirement for strength, weight, and thermal conductivity. Next, we go the CNC machining process. First, we do the roughing part. It is to remove excess material quickly using larger tools to minimize machining time. Next, we go to the semi-finishing part, that is performed to bring the block closer to its final dimensions. By using tools with a smaller diameter, it can achieve the finer details. Next, we go to the finishing part, that is carried out to achieve tight tolerance and smooth surface finishes. Next, we go to the drilling and tapping part. This is a part like hole for bolts, studs, and other components are drilled and tapered using specialized tooling to ensure accurate alignment and thread quality. Lastly, we have the milling operation. Is going to integrate features such as coolant passage, mounting points, and sealing surface. Okay, for the quality control and inspection, it is throughout the machining process. Regular inspections are conducted using precision measurement tools like coordinate measuring machines (CMMS) and gauge. So in the surface treatment, is such as shot blasting, honing, or surface coating may be applied to enhance their durability, reduce friction, or improve sealing of the block engine. Lastly, we have a final assembly preparation. The engine block need to undergo final cleaning to remove any debris or machining fluids to prevent damage or contamination during subsequent assembly process. So, in using CNC machine for block engine manufacturing, can meet precise specification for performance, reliability, and longevity of product. Each step requires careful planning, programming, and execution to achieve the desired results efficiently and accurately.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amiru. Matrix number CD210191. I'm from Group 9. Okay, for my part, I will talk about result and discussion. For this section, there are two main points that I want to tell. I want to present. First is sustainability. Okay, sustainability is environmental, focus on preserving natural resource and ecosystem to ensure the well-being of current and future generation. This means that the process of manufacturing is ensure that there are more resource to use in the future, and also to minimum the waste of the product by using the manufactured method that we have researched. Sustainable, there are many type of sustainable in this part, but we only have three: sustainability, environmental, energy, and waste. For the second part is finished product. We'll talk about what the finished product of our research is our study, which using sand casting, manufacturing, and CNC machining. Okay, next part. Okay, for the first part is CNC machining. Okay, first is material efficiency. CNC machining is highly precise, which reduce material waste. This subtractive nature of the process can create significant amounts of metal shaving, but they can be collected and recycled using advanced software for optimal material removal paths can further minimize waste. For the second point is energy consumption. Modern CNC machines are designed to be energy efficient, implementing practice like turning off machine when not in use, using energy efficient motors, and optimizing cutting speeds and fits can significantly reduce energy consumption. Additionally, using renewable energy source to power CNC operation can greatly enhance sustainability. 4.3 is waste management. Efficient collection and recycling of metal chips and shaving generated during machining contribute to sustainability. Proper disposal or recycling of used coolants and lubricant also play a crucial role in reducing environmental impact. By implementing this waste management practice, the CNC machining problems can minimize its environmental footprints. And the other parts is sand casting. Okay, first is material recycling. Using recycled sand for mold making significantly reduce the demand for virgin sand, minimizing environmental degradation. Additionally, scrap metal can be reused in the casting process, reducing the need for the new material. Number two is energy efficiency. Implementing energy efficient furnace such as electric induction furnace reduce energy consumption compared to traditional furnace. Heat recovery system can can capture and reuse waste heat generated during the melting process, further improving energy efficiency. Number three is waste management. Effective management of waste material, including recycling, used sand, and properly disposing of non-recyclable waste, helps reduce landfill use. Byproduct from the casting process can often be repurposed or recycled, contributing to overall waste reduction. And finally, I will talk about finished product. By using two type of manufacturing process, there will be have two types of product. Okay, the first product is for high quality engineering blocks or high performance engineer block. For the second is mass produced engine blocks. For high quality, it relates with the CNC machining, which is exception, precision, and consistency. Consistency. Okay, for the mass-produced engine blocks, it's related with sand casting. This is because it has the adequate precision, higher variability. It's suitable for mass-produced car to use. For the material efficiency, optimize raw material use and reduce waste. For the high quality, for mass produce, it efficient in producing large volume. For the cost, high quality is a high operational cost. It means there are more costs than the mass produced engine blocks. For production speed, is high quality engine blocks by using CNC machining is that takes longer cycle time. Meanwhile, for the mass produced using sand casting has a lower it has fast production speed. For energy significant but can be reduced with energy efficient machine for CNC machining. Sand casting is lower compared to CNC but varies with furnace type. What type furnace we that we use, it will affect our energy consumption. Finally, the application for the high quality engine blocks, it always it's not always but almost used by high performance beauty high performance and luxury vehicles. The other side is which mass produced engine block is for common car or mass produced market vehicle. Thank you.
So the last one is conclusion. So in conclusion, the goal of this study was to pinpoint difficulties encountered throughout the engine block production process. So it addressed the specific case study and studied the relationship between engine blocks, production, and sustainable practice. So the engine blocks were manufactured using CNC machine and sand casting, each of which have unique benefits and drawbacks that all works together to produce products of the highest caliber. So it's an economical process that works well for large-scale manufacturing, conservative resource, and cutting down on waste. So this study demonstrate how crucial it is to include sustainable practice into the production of engine blocks using techniques like sand casting and CNC manufacturing. So, manufacturer in the automobile sectors may improve product longevity, maximize resource efficiency, and lessen environmental effect by doing this. So, I think that's all from our group. Thank you for watching.